Hey 8th grade, this is Ms. Harkness, and this video is for Eureka Module 3, Lesson 10, where we are going to be looking at angle-angle criterion for similarity. So this is just a quick rundown of how to solve these types of problems. All right, the directions on number 1 say to use a protractor. Since we've struggled with that so much, I shortcutted here, and I just drew in this boulder left triangle, and then I copied and pasted it to create a similar one, since a similarity of figures is going to maintain angle measurement. So now what I'm going to do is I'm going to measure this left side and this right side. All right, I went ahead and used my ruler, and I found that the triangle on the left is 4 centimeters, and since it is an equilateral triangle, all 3 sides of it are 4 centimeters, and then the one on the right is 2 centimeters long on each side. And if I measure my angles, I will find that it is 60, 60, 60. I don't want to multiply, I want to add, which equals my 180 degrees. Now if I were to move on and draw 2 new pair of triangles with 2 pairs of equal angles, then measure the sides, I would find that the third side is proportional. Okay, let's look at number 3 from the classwork. It says, are the triangles similar? Present an informal argument as to why they are or are not similar. Well, let's see. We've got 31 and 31 for A, 103 and 103 for our B's, and then the triangle sum theorem tells me that every triangle adds up to 180, so that means that angle C is 46 degrees on both of them. So my informal argument would say, yes, they are similar. Because they have the same angle measure. Sorry, that got a little cramped over there. Okay, so let's look at number 4, for example. A is 31, A is 31. B is 103, B 85. No, they are not similar. Because the angle measure does not correspond. Because the angle measure doesn't correspond. Let's look at 2 more. All right, just kidding. We're going to look at 1 more. Are the triangles similar? Well, 72 became 72. 60 became I don't know what. And 48, I don't know, corresponds. So let's start by finding angle C, just because I have more room right here. The triangle sum theorem says every triangle adds up to 180. So we're going to take away the 72 that we know, and we're going to take away the 60 that we know. And that tells me that the missing measure, C, equals 48 degrees. Voila. There it is on the other triangle as well. They are indeed similar. So keep this in mind, that even though they don't give you all of the information straight up, we can see that A and A prime have the same measure. You're going to need to use a little bit of subtraction sometimes to find the third angle, and then use that third angle to see if it is indeed angle-angle criterion. Since A and C are the same, B has to be 60. There's no other logical or reasonable value for B other than 60 degrees, because we know that every triangle adds up to 180 degrees. Okay, here's 4 examples I want us to take a look at. Let's look at this pink one for a minute. If A is 53 and A prime is 53, looks good. B is 72, but we don't know B prime. And then C, we also don't know, but we know that C prime is 55. We can use the triangle sum theorem to find out that C is in fact 55 degrees, So yes, they are similar. So go ahead and pause the video if you need to, and go ahead and see, is this hunter green one over here? Are those similar triangles? Are these blue ones similar triangles? And are these red ones similar triangles? All right, you can see that I went ahead, found the third measurement for my pre-image on each set of angles, and found that yes, all 4 of these examples on this page are similar figures. All right, best of luck on your classwork and your quiz.